Welcome to Maths with Jade. In this video tutorial, we'll be looking at set notation and shading regions on Venn diagrams. Before we start, we need to define a few things. Set theory is a branch of mathematics that focuses heavily on logic. It is often combined with Venn diagrams and therefore can be used with probability. A set is a collection of things. And unless you've been living in a hammock in a deserted island, then you should know what Venn diagrams are. They are illustrations that use circles to show the relationship among things. So here are some ridiculous but quite funny Venn diagrams that you might have seen floating around social media. These types of Venn diagrams, though, are very troubling to a mathematician because they're often completely incorrect or mathematically questionable at best. I'm going to talk you through how to make a Venn diagram of your own. So I'm going to let A equal prime numbers, and then I'm going to draw a circle for A, all the prime numbers. And then I'm going to let B equal even numbers, and I draw a circle for B. Nice and simple. Now I'm going to place the numbers 1 to 10 in the correct place on the Venn diagram. As we do this, I'm going to talk you through set notation, and I would section off a corner of your page and jot this down. You'll notice that the two circles are contained within a rectangle. And just like we've labelled the two circles A and B, we're going to label the rectangle this symbol. And this symbol means the universal set. And it means everything considered in the problem. In this case, all the numbers 1 to 10. Now we need to decide where in the rectangle each of those numbers go. Well, the number 1 is not a prime number because it only has one factor, and it is also not an even number, so it needs to go outside the two circles but within the rectangle. The number 2 is a prime number and it is also an even number, so we need to place it in the middle where it is within both circles A and B. And now the number 3 is a prime number but not an even number, so it needs to go in just A. And then the number 4 is an even number but not a prime number, so it needs to go in just B. And we just continue placing the numbers in the correct position until we have placed all the numbers 1 to 10. The reason I've picked such a simple example for this is to talk you through set notation and new symbols. You can see set notation as kind of like a language. So N of A means the number of elements in A. To find the number of elements, I just want to count how many numbers are in A. And in this case, there's 4 because 3, 5, 7 and 2 are within A. Now this symbol here means is an element of. So 6 is an element of B because 6 is within B. This symbol means is not an element of. It looks like the element symbol, but there's a line going through it. And 6 is not an element of A because it's only in B. I would take some deep breaths here because I have a lot more for you. This symbol, A dash, means not A, which is all of the highlighted region. And we would write this as a set. So we would put all the numbers that we have in that region that's highlighted in a bracket, just like we did with the universal set. B dash means not B. So if I want to list that set, I would identify all the region that isn't B, so the highlighted region, and then list it in brackets. Now for the tricky part. If you see something that looks like a U, you need to think U is union. And union doesn't mean anything without two things to go before and after it. So this means the union of A and B. Essentially, A or B or both together. If I show you this highlighted, it becomes very clear. I can have all of A, I can have all of B, and I can also have where they overlap. I like to see the symbol for union as a salad bowl. I can throw all of A in and I can throw all of B inside. It will hold both A and B. Our next symbol is kind of similar, but it's an upside down U, so it kind of looks like an N. If you see N, think intersection. And so let's look at the intersection of A and B. And it means this middle bit here because it has to be A and it has to be B. So in this example, the intersection of A and B is simply 2. The way I see this symbol is a claw at an arcade. It doesn't want things that are just A or just B. It will only take the prizes that are both A and B. I just have one more symbol to show you, and it's this one. It's nice and easy. It's a 0 with a line going through it, and it means an empty set. There are no empty sets in our previous example, so I'm going to give you a new example. Let D equal the types of dinosaurs that still roam Earth. Well, D is an empty set because, as far as we know, all dinosaurs are extinct. Whew, that was a lot to take in. I do suggest pausing the video now and just making sure you understand what all of these symbols mean using the example I've provided. So now let's get to the part that most people struggle on, and that's shading regions. So let's say I want to shade the region that satisfies this weird looking thing. Well, first I want to translate it using the definitions that we saw previously. Now it's the end shape, so it's the intersection of A and not B. So this is A, we have two regions that are A, and we have two regions that are not B. Because it's the intersection, I want to shade the region that contains both A and not B. Now let's have a go at another one. This one looks almost the same, except instead of the intersection, I have the union. Now with the union, I can shade all of A, which means this part, and this middle part. And then I can also shade all of not B. Remember the salad bowl? Both things can go in their entirety. Okay, a new example. Now this one looks really complicated, but if we translate it, we're looking at the union of the intersection of A and B and not A. Because this is such a mouthful, I'm just going to look at one side of the union first, this side. So this side says the intersection of A and B, so I'm going to find that. So we have two regions that are A, this one, and only one region that is B, this one. Now the intersection is where both of those meet, so we have just this centre bit in the middle. We've done the hard part, now we just need to make it the union with not A. And that's easy to find, it's all that isn't A. I'm going to give you one more example and then you're on your own. So now we have three sets within the universal set. And I want the intersection of not the union of A and C and not the union of A and B. Well, this looks absolutely ridiculous, so I'm not going to tackle it all in one go. No, I'm going to highlight one side first and deal with that. So we want not the union of A and C. So I'm going to just cross out all that I know to be the union of A and C. So all of A and all of C. Now we want to do the same with not the union of A and B. Well, most of B is already crossed out and so is all of A. So we only have one section that we need to cross out for this and it's there. Now I have put crosses in all the areas I cannot shade, I'm left with just what I can shade. And when I'm done with a question like this, I always remove my crosses so they're not mistaken as shaded regions. Now it's your turn. This is not an easy task, so I want you to shade the regions that satisfy the following, but do take your time and really think about it. Pause the video now. Okay, let me run through the solutions with you. For the first one, it cannot be A and it also cannot be B because it's the intersection of not A and not B, so you should have shaded all around the outside. For the next question along, I would identify the brackets first, so put a cross in not A and also both of B, and then we know that it's the opposite of that, so shade what's not got a cross in. The next one along is nice and simple. We want the intersection of A, B and C, which just leaves us with the middle section. So for the fourth question, it has to be not the intersection of A and B, and also C. So first let's cross out what is the intersection of A and B, because it cannot be that. And now I can shade all that is left that is also C. Well done if you've got all of those so far. We get into the trickier ones now, but it's not too tricky if you take it side by side. So first, let's find the intersection of A and B. Well, that's the middle section here. And now I want to find what isn't the union of A and B. So I can put a cross here and I can put a cross here. I'm not going to put a cross in the middle because that's already shaded. And now I'm going to shade everything that doesn't have a cross in. The final question is actually the same thing but on a different type of Venn diagram. So first, let's look at the intersection of A and B, and the only place that is A and also B is that middle section. Now my next part is to identify what I have left of the union of A and B. So that's just this section here. I'm going to put a cross there, and now I can shade everything else that's left. Thank you for watching, and well done if you made it to the end of this tutorial on set notation and shading regions on Venn diagrams. This has been Maths with Jade. Please do like this video if you found it useful, subscribe to my channel, share this video, and all comments below are welcome. See you next time.